Good afternoon. My name is Sveta Milusheva. I'm a senior economist in the Development Impact Department at the World Bank, and I'll be presenting research on rapid poverty estimation using ready-to-use mobile phone data, applying this to Cote d'Ivoire. Poverty mapping is really key for policymakers to know where they need to target interventions, such as cash transfers, but oftentimes we don't have data that allows us to map poverty at a lower spatial granularity that is necessary for effective policy making. So how can we generate these more detailed poverty estimates more frequently and in order to be able to support policymakers? One opportunity is to leverage mobile phone data. The way that people use their phones, how many calls they make, how often they recharge, can be related to their income and could potentially help us provide more frequent estimates of poverty at a smaller geographic level. And so we test out using metadata from Cote d'Ivoire, specifically working with Orange Cote d'Ivoire and a sample of 800,000 users where we generate aggregated information. In particular, we have Orange generate for us a set of features. One is mobility features that look at movement between different communes. The second is behavioral features, so at the individual level, the number of calls at night, for example, or a number of SMS per person per month. And then a set of business features, which are already generated by the mobile phone provider, looking at things like number of SMS and top-up amounts. We aggregate this at the commune level and combine with remote sensing data. We test out 5 different machine learning algorithms, and our aim is to predict wealth from the EHCVM, which is a survey in Cote d'Ivoire, and we also test out different combinations of features. We find that of the 5 models, the ElasticNet and BHM do best, with the Bayesian hierarchical model being the best one with a Pearson correlation of 0.8 and an R-squared of 0.61. And we also see that we measure wealth much better than we're able to predict poverty or MPI. We can map this. So on the left, we're looking at mapping using the survey data. In the middle, we compare that to mapping of poverty using the predictions from mobile phone data. And we see that those are very much aligned, but then the mobile phone data allows us to predict at a much more disaggregated level at the commune level on the right. And when we look at combinations of different features, we find that if we just use the KPIs and remote sensing data, we are able to get a prediction that's almost as good as combining all of the different features. And as a takeaway, the reason that this is important is because it means that while we are able to predict poverty using mobile phone data, we can use these low-cost features that are generated automatically by the mobile phone provider to do so and operationalize the use more effectively. Thank you.